Hello folks, we come to the miscellaneous exercise chapter 9 and this is our part 1 video and this is our question number 1. They ask us to show that the ratio of the m plus nth term and the m minus nth term is twice the ratio of the mth term. So right away we get the formula and get across doing this is an arithmetic progression problem. So we have, let's consider this, let's consider a m plus n by a m minus n. That is where a represents small a represents the first term and d represents a common difference. It will be given as a plus check the question. That's all the ratio, it's a sum. Yeah, so we will also consider the sum. Plus a plus m minus n minus 1d. You can have a and a added up, it will become 2a, d is common, and then we can have these things added up. So let's see what we get. We have the n cancelled and then you have 2a plus d times m plus m to m and minus 2. This can be always written as 2 times m minus 1. So 2 can go overall common, a plus d times m minus 1, which could be called as 2a m. This is the mth term, a plus d times m minus 1. That's the formula for the mth term. So you have that as 2am, and that's what they have asked us, hence proved. That's about it. We quickly go to the second question where they say that there are 3 terms in an AP such that their sum is 24 and their product is 440. You have to find out the terms. Now it's your discretion, you can use the terms as you want, but generally when 3 terms in an AP come, we generally use the terms a minus d, a plus d. Generally that works good. So we can make an assumption like this: let a minus d, a plus d be the required terms, and then therefore the sum, which is given as 24, will mean that it is a minus d plus a plus d, which will come to 3a, which is 24. We can work this out. A comes to 8 in that case. So also they give us the products also. The product is 440, which means it is a into a minus d into sorry, a for us it's 8. This is 8 minus d into 8 plus d is equal to 440. 8 can come up on the other side, and this is a plus d, a minus d, so it is 64 minus d squared, and the 8 can come on the other side. 8 5s are 40, again 5s. You can have the d squared going on the other side, so you have 64 minus 55. That's 9. And d therefore will come to plus or minus 3. They ask us to find out the terms. So you could have for the AP is in the first case a minus d, that means 8 minus 3, that's 5. Next case, sorry, 8 minus of minus 3, so that's 8 plus 3, that's 11. The next case it's 5. First case the d was 3, and then the next case d is minus 3, so that's how you get the answer. Now we can quickly come to this third problem where they say that the sum of the first n terms is called as S1, sum of first 2n terms is called as S2, and sum of first 3n terms is called as S3. If that is the case, you have to show the relation. That is, I just checked the relation, it's correct. Yeah, S3 is 3 times S2 minus S1. Now here, let A comma D be as usual or represent as usual. So S1, which is the sum to n terms, n by 2 times 2a plus n minus 1d. S2 is sum to 2n terms, so 2n by 2 into 2a plus 2n minus 1d. And S3 is 3n terms, so 3n by 2 into 2a plus 3n minus 1d. Now, they ask us to show all this S3 and all that. So, S3 is there always with us. If you want, you can just expand it. It will come to 3an when we expand, and 3n into 3n minus 1d by 2. This is what comes on expansion. And let's consider the other side. Consider 3 times S2 minus S1. So, what does it come to? S2 for us, n into 2a plus 2n minus 1d, and S1 is minus n by 2 times 2a plus n minus 1d. Okay, let's open this up and see how this works. It is 2an plus n into 2n minus 1d. This also let's open up, so 2 cancels, minus an remains, and minus n into n minus 1 d. You have these as like terms. So 3 times 2an minus an is just an. And here we have maybe nd common. So 2n minus 1 in the first bracket, and in the next bracket minus n minus 1. So minus n plus 1. How does that further work? 3 times an plus nd plus 1 minus 1. That's n remaining. Yeah, 2an. We didn't take it right, because 2an over here, then n into n minus 1 by 2 is there. So what will happen is, if you could take nd common, 2n minus 1 stays over here, but here there's a 2 coming up. So that part of solving we have to take care. So here it will be an plus nd, and then as we did it over here, we'll have to equalize. It doesn't work so easily. We'll have to check this. Doesn't work so easily. It is 2n minus 1 minus n minus 1 by 2, so it has to be equalized into 2 into 2. So this will come to 4n minus 2 minus n plus 1 then by 2. So it will be 3 times an plus nd. Now this is 3n and this is minus 1 by 2. So when we work out, it will be right. So it will be 3an, then when we take it out, 3n into 3n minus 1 times d by 2, and that's the same as S3, and that's how we prove whatever they have asked us, hence proved. So that's about problem number 1, 2 and 3, and that's our part 1 video. With the remaining problems, we are coming in the next part. Thank you.